We decided to do an experiment involving one of America's most popular and common drinks, coffee. The majority of people drink coffee every single day, some even claiming that they need coffee in order to function properly. Now, some like it sweet, some like it black, or some like it really heavy with milk or sugar. We all know how to sweeten hot coffee, but what about iced coffee?
Sweetening up iced coffee is harder than it seems because not all the sugar can dissolve in a cold substance. This is because when the solvent, the thing that is dissolving the substance, or coffee, is at a lower temperature, its kinetic energy is lower. This makes it harder for the coffee to break the intermolecular bonds between sugar molecules. When the coffee can't break the intermolecular bonds between sugar molecules, the sugar stays as a solid. So, how do you know how much sugar you can put into your iced coffee? Or an even better question, what kind of sugar would dissolve the most in coffee? That's what our lab will help you discover. We will be testing the solubility, or how much something dissolves, of sugar versus artificial sweeteners so that every type of coffee drinker, especially iced coffee drinkers, can get their drink's sugar content to be to their perfection.
First, we filled 2 beakers with 200 milliliters of coffee. We put 12 teaspoons of Splenda into one of the beakers and 12 teaspoons of sugar into the other. After putting the sugar in, we stirred each beaker with stirring rods until the coffee dissolved as much sugar as it could.
Then, we used a ring stand, funnel, and filter paper setup to separate the undissolved sugar through filtration. After pouring the coffee into the funnel and filter paper, the undissolved sugar would stay on top of the filter paper while the coffee goes through the filter paper.
After the filtration, our plan was to let the filter paper dry overnight and take the mass of it the next morning. To find out the mass of the sugar versus the Splenda, we would subtract the mass of the filter paper with the sugar on it by the mass of the filter paper by itself, which we recorded in the beginning of the experiment. Then, we would convert the mass of the sugar into teaspoons because the mass of sugar versus Splenda is different. Sadly, this is not how our experiment went.
We realized while doing the experiment that the coffee dissolved all of the sugar and the Splenda, so no excess sugar would have been undissolved. So we cannot compare the solubility of Splenda versus sugar with the results from this experiment. In order to reach some sort of conclusion, we decided to do some experimentation at home.
At home, we took 2 cups and put 1 cup of coffee into each one, this time with milk in it to make it more realistic. We thought putting milk in it would help us reach a more accurate conclusion due to how most people drink their coffee with milk. We also put the same amount of ice cubes in each cup to lower the temperature of the coffee by the same amount.
First, we put a quarter cup of sugar into one of the cups, and then a quarter cup of Splenda into the other. After stirring it well and letting any excess solute settle, we observed that all the sugar had been completely dissolved. So, we put another quarter cup of sugar and Splenda into the cups. Still, the coffee continued to dissolve all of the sugar. We continued this until we reached a whole cup of sugar in each cup, and once we got to this amount, the solution has reached its saturation point. We observed that there was very little solute at the bottom of each cup once 1 cup of sugar and Splenda was in each one. There appeared to be a little bit more sugar at the bottom of the cup of sugar than there was Splenda, but overall, the amount of solid in each cup was about equal. Some possible errors could have been that we based our observations and data off of qualitative data rather than quantitative. We based our conclusions off of visual observations since we did not have proper materials at home like we did in school. Also, we were not able to control the temperature because we did not have the proper tools, although we did keep the temperatures of the coffees as equal as we possibly could.
In potential follow-up experiments, we could repeat our first setup, except now with different types of coffees, for example, from Dunkin' Donuts and from Starbucks, and we can now use different brands of sweetener. This would help us reach a much broader conclusion. We did learn about the solubility of sugar, which connects to our solubility unit. We didn't reach the conclusion we wanted with this experiment, saying our results were that a cup of iced coffee can dissolve 200 grams of sugar or 48 packets of Splenda. And not only does that sound extremely unhealthy, but it tasted absolutely disgusting. Instead, we reached a different conclusion. First of all, we realized that sugar is very, very soluble in water. We also realized that if you have reached the point where no more sugar will dissolve in your coffee after stirring it around as much as you can, you should probably stop putting in more sugar for your own health.
And if you really want to have a super sugary coffee, We recommend that you use Splenda since it is a 0-calorie sweetener and it can be dissolved as much as sugar can. Now, this may not affect most of us because a lot of us don't put 200 grams of sugar into our coffee, but next time you buy a Dunkin' Donuts iced coffee and the extra sugar you put in it won't dissolve, you will know why.
If we could pose one great explanation question that could potentially be used on a test next year based off of our experiment, we would ask what factors can change the solubility of a substance.
Thank you for watching!